Hello friends, the topic for today is Arduino Uno R3 Pinout. Arduino Uno is a microcontroller board based on Atmega 328P. Uno means one in Italian and is named to mark the release of Arduino 1.0. The Uno and version 1.0 will be the reference version of Arduino moving forward. Now today we have Arduino Uno R3, that is revision 3. In today's video we'll discuss the Arduino Uno board, revisions, technical specifications and pinout and programming of Arduino Uno R3. Let us start. Welcome to our channel Engineering and Technology for You. The topic for today is Arduino Uno R3 Pinout. Introduction. Arduino Uno is a microcontroller board based on Atmega 328P. We already covered this topic Atmega 328P in the last video. It has 14 digital input-output pins, of which 6 can be used as pulse width modulation PWM outputs, 6 analog inputs and 16 MHz crystal, a USB connection, a power jack and an ICSP header and a reset button. It contains everything needed to support the microcontroller. Simply connect it to the computer with USB cable or power it with AC to DC adapter or battery to get started. Uno means one in Italian and is named to mark the upcoming release of Arduino 1.0. The Uno and version 1.0 will be the reference version of Arduino moving forward. So this is the Arduino Uno board. Then let us see the revisions. The Uno differs from all preceding boards in that it does not use the FTDI USB to serial driver chip. Instead, it features the Atmega 16U2, Atmega 8U2, that was for up to the version R2. So now for R3 it is Atmega 16U2, programmed as USB to serial converter. Then revision 3 of the board has following new features. First is Pinout, 1.0 Pinout. So here with R3 they have added SDA and SCL pins that are near to a REF, this analog reference pin, and 2 other new pins placed near the reset pin, the IO REF, that is IO reference, allow the shield to adapt to the voltage provided from the board. In future, shields will be compatible with the boards that use AVR, which will operate with 5 volts, and with the Arduino Duo that operate with 3.3. So these are the coming things. The second one is not connected pin, that is reserved for the future purpose. Then the stronger reset circuit. The reset circuit is stronger now in revision 3. Then Atmega 6U2 replaces 8U2. These are some of the revisions in the release 3 or R3. Then technical specification. Microcontroller Atmega 328P, operating voltage is 5 volts, input voltage 7 to 12 volts. Then input voltage limit is 6 to 20 volts. Then digital IO pins 14, of which 6 provide PWM output. Then PWM output pins 6, analog input pins again 6. Then DC current per IO pin is 20 milliamps. DC current for 3.3 volt pin, it is 50 milliamps. And flash memory is 32 KB. Now these are all in Atmega 328P. SRAM is 2 KB and EEPROM or EEPROM is 1 KB. And clock speed is 16 MHz. LED bulletin, that is 13, is given as the. Then length is 68.6 mm, width is 53.4 mm, and weight is 25 grams. Then let us go to the pinout. Now here we see the different pins. This is the top view which is taken so that we understand the pins. Now here we have the digital pins in green color 2 to 13. Then this is the analog reference, A reference, ground pin, and then we have on this side RX and TX. They are with the digital pin 0 and 1. They are shown in dark green color. Then on this side we have the analog pins, and then we have the power pins. Then this is the reset switch. Then this is ICSP. Then on this side also we have the USB and the microcontroller. So they are shown here. Now we can again come back to this diagram by referring to this. Analog reference pins orange in color. Then digital ground light green. I have already shown you this. Then digital pins 2 to 13 green in color. Then digital pins say RX and TX and RX. So pin 0 is for this and 1 is for RX. So this pin cannot be used for digital I/O in special case. Then reset button IS1, that is dark blue. Then in circuit serial programmer ICSP, that is in blue green. Then analog pins, they are again light blue. So let us go back. So these are the analog pins, light blue. ICSP again it is light blue, and this is the reset button. We'll move forward again. Then power and ground pins, power orange, ground light orange. Then external power supply, that is here in, that is 9 to 12 volts DC, and X1 pink. These are shown here. You can just see. This is, it is not this is the external power supply. It will shown in this pink color, and this is another supply. Then coming back, then toggles external powers and USB power. Place jumper on 2 pins closest to the desired supply. SV1 purple color. So USB used for uploading the sketches to the board and for serial communication between the board and the computer. It can be used to power the board yellow. So it is in yellow color. So you can again see it. This is the USB. And these are the power supply pins, and this is the IC for the microcontroller. So we have seen this. Again we can see some of the details in the next diagram here. Now the same layout is there. So these are the digital pins 2 to 13, then ground A reference, and again on this side we have RX and TX 0 and 1. These are used for. Then along with that the external interrupts, interrupt 0, interrupt 1 is there, and then we have pins for the SPI, that is SCK, MISO, MOSI and SS. These are the pins for the SPI interface. Then I2C interface we have SDA and SCL. They are now visible here. Then ICSP for USB interface is given here, and this ICSP for ATmega 328, it is given here. So it will again have the VCC, MOSI, then SCK and MISO and reset ground. These pins, 6 pins are there. So you can see this external power 7 to 12 volts DC, you can put it here. and this is the USB connector for the computer. So now here in this diagram many things are clear, and then I2C we have SCL and SDA, these two lines along with these analog inputs. These are the power lines. So some of the things which were not clear in the previous diagram are clear here. This is the crystal. Then let us see the description of the pins. First, the power pins. So here we have Vin, the input voltage to the Arduino board when it is using the external power. So that will be the power source, as opposed to 5 volts from the USB connection or other regulated power supply. We can give external. You can supply voltage through this pin, or if supplying voltage via power jack, access it through this pin. So that way you can make use of this Vin pin. Then 5 volts. This pin outputs a regulated 5 volt from the regulator on the board. The board can be supplied with a power either from DC power jack, that is 7 to 12 volts, or the USB connector 5 volts, or the Vin pin of the board 7 to 12 volts. So this is the Vin pin. So we can either connect the supply through the USB or this Vin pin, or from the DC power jack. Supplying voltage via 5 volts or 3.3 volts pin bypasses the regulator and can damage your board. So we generally don't advise this. Directly you can make use of the voltage regulator which is there in that. Then 3.3 voltage supply generated by the onboard regulator, maximum current drawn is 50 milliamps. So for this the current will be more. For 5 volts it is 20 milliamps, here it is 50 milliamps. Then GND, that is the ground pin. Then IO reference. This pin on the Arduino board provides the voltage reference with which the microcontroller operates. A properly configured shield can read the IO reference pin voltage and select the appropriate power source, or enable voltage translator on the outputs to work with 5 volts or 3.3 volts. So we have choice whether we want to work with 5 volts or 3.3 volts. So accordingly, with the help of this pin we can make use of it. Let us continue with the digital pin description. Each 14 digital pins on the Uno can be used as an input or output using pin mode, digital write and digital read functions which are available in the library. They operate at 5 volts. Each pin can provide or receive a maximum of 40 milliamps and has an internal pull-up resistor of 20 to 50 kilo ohms. Then in addition, some pins have specialized functions. So first is serial communication. We have 2 pins, digital 0 pin and digital 1 pin. So this is TX and digital 0 is RX. They are used to receive and transmit serial data. These pins are connected to the corresponding pins of ATmega 16U2 USB to TTL serial chip. So this is in R3, the ATmega 16U2 is there in place of 8U2. Then we have the external interrupts 2 and 3. These pins can be configured to trigger an interrupt on low value, a rising or falling edge, or a change in value. So all types of triggering are possible for the interrupts. So we can use these pins for the external interrupt. Then next we have the PWM 6 pins, that is 3, 5, 6, 9, 10 and 11. They will provide the 8-bit PWM output with the analog write functions. Then for SPI we have 4 pins, 10 is for SS, 11 MOSI and 12 MISO and 13 SKC. These pins support the SPI communication using the SPI library. Then LED 13, there is a built-in LED driver for digital pin 13. When pin is high value, the LED is on. When the pin is low, it's off. Then two-wire interface, that is using the A4 and A5 lines. Analog. Here SDA and this SCL. There is the data line and this is the clock. So they support the two-wire interface communication using the wire library. Then analog pins. The Uno has 6 analog inputs labeled A0 to A5, each of which provides 10 bits of resolution. That is 2 raised to 10. That is 1024 different values. By default, they measure from ground to 5 volts, though it is possible to change the upper end of the range using analog reference, A reference pin and the analog reference function. Then there are other pins, that is A reference pin, voltage for analog inputs used with the analog reference. Then reset pin, bring this line low to reset the microcontroller. Typically used to add reset button to the shields which block the one on the board. So then coming to the programming, there are various ways of programming the Uno board. The Arduino Uno can be programmed with Aurdino software, that is ID, Integrated Development Environment. So this is available on the website. You can visit the website. Then here we'll have to select the Arduino Uno from the tools, then board menu according to the microcontroller on your board. Then the Atmega 328 on the Arduino Uno comes pre-programmed with bootloader that allows you to upload a new code to it without the use of external hardware programmer. It communicates using the original STK 500 protocol. So when we are buying it, at that time it will come with pre-programmed with the bootloader. Then you can also bypass the bootloader and program the microcontroller through ICSP, that is in-circuit serial programming header, using the Arduino ISP or any other thing. Then Atmega 16U2, that is, or 8U2 in the previous revised boards. Firmware source code is available. The Atmega U2 or 8U2 is loaded with the DFU bootloader. So that is a bootloader which is multifunctional bootloader. So this is, we can activate this by, say, revision 1 boards by connecting the solder jump on the back of the board and then resetting the 8U2. And for the 16U2 boards, there is a resistor that is pulling the 8U2, 16U2 this line to ground, this WB line, making it easier to pull the DFU mode. So this mode we can program the Uno. Then last is you can use the Atmens Flip software that is used for Windows and the DFU programmer which is on Mac OS or Linux to load new firmware, or you can use the ISP header with external programmer overwriting the DFU bootloader. So there are various ways of programming. You can do the programming with any of these ways. Then with this we come to the end of the video. If you like the video, please press the like button, share with your friends and subscribe to our channel Engineering and Technology for You. Then if you want to get notified, press the bell icon. So subscribe our channel and press the bell icon to get notified with the future videos. Then if you have any questions, you can contact me on Facebook, Twitter, Gmail or Instagram. Thanks for watching. Have a nice day.
I have you now.